Hello everyone, welcome back to the channel Unknown Physicist. So today we are in our series Mastering MMP. So in my previous video I have done all about linear algebra, which is matrices, and today we are going to start with a new topic which is all about complex analysis. Hope some of you will be familiar with this, but we will do from basics to the higher end problems. Again, this particular topic is really very easy and quite interesting to solve the problems, and it's very important in any point of competitive exams. You can get the answers very easily, and I'm going to share a lot of tricks which is going to save a lot of time for you guys. And if you are a new visitor to this channel, in this channel I do make videos on different concepts of physics. Right now I'm doing two series. One is Mastering MMP, which is completely in English, and the other is Quantum 100, which is in Tamil, but still then you can understand it. So if you like this video, don't forget to hit the thumbs up sign as well as share with your friends. So let's get into the video. So today we are going to discuss about complex analysis. So we will do some of the basic things which is required. So we are going to do all about complex analysis. So before getting into the topic, let us discuss few important things. First is complex numbers. Most of you must be familiar with this complex number. So what is a complex number? So for example, if I have an equation x square plus 1 is equal to 0, this I can write as x square is equal to minus 1. So again, the value of my x is plus or minus under root minus 1, right? So the value of under root minus 1 is nothing but I. Okay. So this I can write as x is equal to plus or minus I. So sometimes we used to say this is our imaginary term and this is called iota. Okay. And then I square is nothing but it is minus 1. So these are some of the really basic things. And generally it is represented as z is equal to x plus iy. So whereas x is your real part, and iy, this is your imaginary part. Iy, this is your imaginary part, such that x and y belongs to real numbers. Okay, belongs to real numbers. This is one thing which I have to convey here. Next is, so I said z is equal to x plus iy, right? So if I'm going to represent it graphically, so let me plot it in a graph. Some point, let this be my x, z is equal to x plus iy. So if I take a conjugate for this, then my imaginary term becomes negative, right? So z bar will be equal to x minus iy. So it will be somewhere here. So this will be z bar is somewhere here, x minus iy, which we call as complex conjugate. We call this as complex conjugate. So these are some of the basic terms which we will be using in complex analysis. And then what is z bar? What is z bar? You have to multiply both of this. So x plus iy into x minus iy. So which is in the form of a plus b into a minus b. So it will be x square minus b square. So it is minus iy the whole square. So x square minus 1, I square is nothing but minus 1, right? So which will be x square plus y square. So this is your answer. So these are some of the basic things, and we'll be discussing some properties. So I'll name these as closure properties. Okay, closure properties. So what are those properties? So for this I'm taking z1 is equal to x1 plus iy1 and z2 is equal to x2 plus iy2. Okay, what z1 plus or minus z2 will be equal to? So it will be x1 plus or, I can separate the real parts and the imaginary parts together. So x1 plus or minus x2 and then plus I into y1 plus or minus y2. So these are some basic properties which you have done during your schooling itself. Next is z1 into z2. So what will be z1 into z2? So it will be x1 plus iy1 into x2 plus iy2, right? So if I am going to multiply, after multiply I have to write the real parts and imaginary parts separately. So I'll write it directly. So which will be x1 x2 minus y1 y2 plus I into y1 y2 sorry x1 y2 plus x2 y1. Okay, so just you multiply, you can split the this will be my real part, this will be my real part, and this term will be my imaginary part. So this is the second property. So this was my first property and this was my second property. And the third one is if I'm going to divide z1 by z2. So what it will be? X plus I y1 by x1 I y1 plus x2 plus I y2, right? So there is an imaginary term. So I have to take complex conjugate. So I have to multiply with x2 minus I y2 divided by x2 minus I y2, right? So in numerator it will be, I'll be splitting the real terms and imaginary terms separately. So which will be x1 x2 plus y1 y2 divided by, so this is in the form of a plus b into a minus b. So which will be x2 square plus y2 square, and then plus imaginary part into, my imaginary part is x2 y1 minus x1 y1, sorry x1 y2 divided by x square plus y2 square, x1 x2 square plus y2 square. So this is what is in your denominator. So these are some of the basic properties which you need to know. Next is, we are going to see is, we are going to represent a complex number z in different forms. So first let me take in the form of vector. So how do I represent in vector? So let me plot a graph for it. So there is a point which is ax and ay. Okay, ax and ay. So this distance is ay and this distance is ax, and the angle made over here, it is theta. Let me consider this as a vector. Okay, so here for my ax and ay, my a vector will be equal to ax I cap. So I am representing vector form. So ax I cap plus ay j cap, right? So if I want mod of a, then what would be? It would be under root ax square plus, you no need to consider the imaginary term. So it will be ay square. So I want tan theta. So from this graph, you can write tan theta. So tan theta is given by opposite by adjacent, I'm sorry. So which will be ay by ax. So let us see how complex number is represented in Cartesian form. So let us see how a complex number is represented in Cartesian form. Cartesian form. So let this be x-axis and this be my y-axis, and this is an imaginary axis. Okay. So I have a point over here which is x comma y. So this distance it is y, and this distance it is, sorry, to the origin, this it would be x, and this is some z and an angle theta. So here my z, my complex number z will be equal to x plus iy, right? So here I want mod of z. So mod of z will be equal to under root x square plus y square. And I need tan theta. So what is tan theta? Tan theta will be equal to y by x, right? So which I can write here as theta is equal to tan inverse of y by x. So what is this theta? This theta is called as argument of z. This theta is called as argument of z. So this is how we represent in Cartesian form. What if it is in polar form? What if it is in polar form? So in polar form, it is given by, again let me consider point x comma y. So if I want to write in polar form, what this will be? This will be my, this, if this is my theta, this would be my, let this be r. So this will be my r cos theta, and then this region, this would be my r sin theta. Okay. So what is z? Z is actually x plus iy. So I need to find what is my x, what is my y over here. So my x here it is r cos theta, and my y here it is r sin theta, right? So if I substitute in z, so z will be equal to r cos theta plus I r sine theta. So I can take r common from this. So r into cos theta plus I sine theta. So if you remember in the basic formulas, I would have discussed this. Cos theta plus I sine theta is nothing but e raised to I theta. So my z will be equal to r e raised to I theta. So in polar form, this is how you represent your complex number. Again, this is really very important. In few more videos, we will be seeing the implement of this. Okay, and we will see a small note for this. Discuss few notes over here. So I'm going to some of the important points. So before going to the point, what is my z1? Z1 in polar form I am representing, which will be r1 e raised to I theta 1, and z2 will be r2 e raised to I theta 2. Right? So here mod of z1 will be equal to r1. Over here mod of z2 will be equal to r2. And then what is argument of z1? So argument of z1 is nothing but theta 1. And here argument of z2 will be theta 2. So let us see a few properties one by one. So first is product of z1 into z2. So what it would be? r1 e raised to I theta 1 into r2 e raised to I theta 2. So before going into that, what is mod of z1 into z2? Which will be nothing but r1 r2, right? Because I can write this mod of z1 mod of z2 as mod of z1 into mod of z2, so which is nothing but r1 into r2. And then what is argument of z1 and z2? This is z, so z1 and z2, so it will be theta 1 plus theta 2. Okay, theta 1 plus theta 2. So what will be the argument of, the property here is argument of z1 and z2 is given by argument of z1 plus, it is not product, it is sum, argument of z1 plus argument of z2. So now what it is? So your z1 and z2 will be equal to r1 r2 e raised to I into theta 1 plus theta 2. Okay, so you can, this is nothing but your modulus product modulus, and this is nothing but your argument of z1 and z2. Hope you got it. And the second property is z1 by z2 will be equal to, so r1 e raised to I theta 1 divided by r2 e raised to I theta 2. So I will take this to the numerator, which will be r1 by r2 into e raised to I into theta 1 minus theta 2. So what is modulus of z1 by modulus of z2? It is nothing but modulus of r1 by modulus of r2, right? And then next, argument of z1 by z2. So it will be the difference. So theta 1 minus theta 2. So this is what your z1 by z2 denotes. Okay. So this is nothing but argument of z1 minus argument of z2. Hope you got these properties. Again, these will be really helpful while doing the sums in future. Okay. And a small quick recap. So in my first video for the basic formulas, I have discussed this. What is sin x? I can write it as e raised to ix minus e raised to minus ix by 2I, right? And then next is cos x. It is written as e raised to ix plus e raised to minus ix by 2. And then next is sine hyperbolic x. So which is e raised to x minus e raised to minus x by 2I. And then cos hyperbolic x, cos hyperbolic x, so which is nothing but e raised to x plus e raised to minus x by 2I. Okay, and a small task over here, just try it. Okay, what is the task here is, so instead of x, substitute ix, instead of x, substitute ix. So let me do one thing, just try for the others. Okay, so first I will do for sine, so sine x, right? So instead of x I have to put ix, so which will be sine ix is equal to e raised to I into, for x I have to substitute ix, right? So into ix minus e raised to minus I into ix divided by 2I. So which will be what? So this will be e raised to I into I minus 1. So e raised to minus x minus e raised to plus x divided by 2i, right? So now what I'm going to do is I'm going to rearrange the terms. So let me write over here. I'm sorry for the space problem in the screen. So this will be minus into e raised to x minus e raised to minus x by 2i. So now what I'm going to do is I'm going to get this I to the numerator. So what it would be? So when it comes to the numerator, it becomes plus. So which will be I into e raised to x minus e raised to minus x by 2. So what is this? This is nothing but your sine hyperbolic x, which can be written as I sine hyperbolic x. So I've just replaced x with ix. So similarly, you can try for cos, sine hyperbolic and cos hyperbolic. This is just a small task just to get the terms in terms of sine hyperbolic and cos hyperbolic, right? So let us see few more things. If you are done with the task, so what will your answer will be? So for sine ix, you will be getting I sine hyperbolic x, and then for sine hyperbolic ix, I'm not going to say. Don't forget, you have to mention the answers in the comment section. So next, this is your second, and the third it is cos of ix, and then fourth it is cos hyperbolic of ix. Okay, don't forget to mention your answers in the comment section. Sure, if you are doing a correct answer, mentioning the correct answer, I'll be featuring you in my next video. Okay, so next what we are going to see is we are going to see about real and imaginary part, how to find the real and imaginary part. So let me take an example for it. So first question, f of z is equal to sine z. F of z is equal to sine z. So how I'm going to find the real and imaginary part for this? So for z, you have to substitute x plus iy. Okay. So if I'm going to substitute sine of x plus iy. So what is this? Sine of a plus b. What is sine of a plus b? It is nothing but sine a cos b plus cos a. Sorry, sine a is sine x. This is x. Okay. And then cos a sine b. Sine iy. So I have to split the real parts and imaginary parts, right? So which I can write as sine x. For instead of cos iy, if you have used that method like the before task, if you are done with the before task, cos I x, this is what the task was given. So if you have find cos x, it is nothing but cos hyperbolic x. This is nothing but cos hyperbolic x. So I can substitute that way. So this will be cos hyperbolic y plus this cos x, right? So this will be cos x only, and instead of sine iy, this I read myself. So sine of I x is nothing but I sine hyperbolic x. So this would become I into sine hyperbolic y. So finally sine x cos hyperbolic y plus I into cos x sine hyperbolic y. So this is your imaginary part and this is your real part. Okay. So if you have done the previous part, then only you will be getting used with this. So I will give you few more problems as task for this. Try to find the real part and imaginary part for it. So this is a task again. So what is the task? First question it is f of z is equal to cos z. And then second it is f of z is equal to e raised to z. Third it is f of z is equal to e raised to z square. Okay. You can either mention your answers in the comment section or else you can share it in the Telegram group, which is unknown physicist. You can share your answers. I know it is kind of little tough to type your answers, but you can share your answers in the group, Telegram group, which is unknown physicist. So if you are able to do the first task, then only you will be able to do this. Hope you liked the video and understood the concepts. If you have any doubts, don't forget to mention it in the comment section. And in next video, we are going to see all about analytic function. So we will be discussing about the most famous thing in complex analysis, which is nothing but Cauchy-Riemann condition. Again, I am having few more exciting problems over there. So if you like the video, don't forget to share it with your friends and have a practice of doing daily everything. So still then everyone, take care. Bye bye. Have a nice day.